Welcome to the third of the Royal Academy of Engineering's Innovation in Crisis series. I'm Mark Miodownik, Fellow of the Academy and Professor of Materials and Society at UCL, and I'm Chair for this afternoon's question and answer. This Innovation in Crisis series is a part of the Academy's response to COVID-19. Now, of course, the Royal Academy of Engineering, represents engineering in the UK and indeed globally. And the importance of engineering to the pandemic, it can't be understated. Of course, without engineering, there really are no hospitals, there's no supply chains to, deliver PPE, there's no manufacturing of PPE. If you go into any hospital, of course, you just see machines and everywhere. Of course, these are all produced and made by engineers. And then, of course, if you think about, the communication issues and track and trace, and all of these issues which are to do with dealing with the pandemic, of course, they're underpinned and enabled by engineering. So what we've been trying to do in this series is kind of unpick where this engineering has come from, who's responding, and how are we dealing with the pandemic as a sector. And early this month, we heard from individuals involved with setting up the Nightingale Hospital. So again, an important engineering task, setting up a hospital from scratch, very fast. And we also heard last week about a UCL Mercedes Formula One collaboration to rapidly produce within 2 weeks 10,000 CPAP breathing aids, which is an incredible achievement. Today, the question and answer session is about the Ventilator Challenge UK. And now, of course, ventilators, one of the core pieces of technology keeping people alive. This COVID-19 affects the breathing system, and when patients get really ill, they no longer can use their lungs properly, and so they have to be ventilated. And we'll get into what that means in a minute. But the Ventilator Challenge UK was a significant moment. It was, it became clear that the UK needed more ventilators because we could see a peak of patients needing them coming up. We only had a few weeks to do it. And so the engineering sector stood up, and we're going to talk to two individuals who are right at the core of that, still are. It's very exciting to hear from them. And it's really about how the UK industrial technology and engineering businesses from across aerospace, automotive, and the medical sectors came together to produce these medical ventilators for the UK at the UK's time of need for COVID-19. So that's what we're going to do for the next 45 minutes. And how is it going to run? Well, I'm going to hand over to our two panelists in a minute, I'll briefly introduce them and then get them to talk a bit about themselves for just a few minutes each, so that you can hear from them who they are, how they ended up doing this, and what their role was. And then I'll ask a few questions that I think we probably all want to know. And while I'm doing that, feel free to ask your own questions. Use the question and answer feature on the Zoom, and I'll see those, and we'll endeavor, sometimes there's so many questions, it's hard to get through them all, endeavor to kind of put those questions to our panelists. So yeah, please do get involved. Please do post your questions. So without further ado, I'm delighted to introduce you to today's speakers. Firstly, I'd like to introduce Dick Elsy, CBE. He's Chief Executive of the High Value Manufacturing Catapult. So Dick, can I hand over to you to just introduce yourself more thoroughly and to tell us a bit about what your role in this challenge was?
Sure. Well, yeah. Hi. The day job is running the High Value Manufacturing Catapult, and the idea behind that, those who don't know, is it's set up to address the issue where the UK is brilliant at science by any measure, but we've not been great at converting that into manufacturing value add. So our job is translational research. So we help companies scale up challenging new technologies. So we're helping the car industry scale up battery technology with our support of Hoare Manufacturing Group, and at the National Composite Centre, which is one of our centres in the Catapult, we're helping Airbus develop their next generation wing at full scale, 17-metre lengths of carbon fibre being robotically placed. So we're an enterprise that does stuff at scale, and we naturally bring companies together in collaborative projects. Just before I leave talking about the Catapult, it has become the largest Advanced Manufacturing Research Institute in Europe. So it's a fantastic thing that the UK's got this capability. But because we're natural conveners of companies with big technical challenges, we found ourselves in the heart of the response to the government's call to arms for the supply of ventilator systems. And going back to the 16th of March, when Michael Gove in the Cabinet Office put a call out to, it was 100 companies who'd expressed an interest in helping in some way. He presented the rapidly manufactured ventilator system, the RMVS spec, to these 100 industrialists, and then said, right, kind of over to you. And then there was this deafening silence as companies thought, yeah, we'd like to do something, but what the hell do we do next? So as we're natural conveners, I stepped in with my Catapult instincts and said, look, Mr. Gove, I'll pull a few people together and see what we can do. So that principally started the role of my chairmanship of this ventilator consortium. And so I made a few calls the following day, or that evening and the following day, and we set the consortium up at that point. So that basically frames why I got involved in this in the first place, and the role of the Catapult really that brought me to put my hand up.
Thank you, Dick. Well, we'll come back to what it entailed, you saying yes to that, and what you'd signed up to in a minute. But first of all, I'd just like to go over to Dr. Graham Hoare, who OBE FREng, who is the Executive Director and Chairman of Ford of Britain. And Graham, can you tell us a little bit about, well, A, your day job, and B, how you ended up involved in this ventilator challenge?
That's great. Good to be here. So my day job is Chairman of Ford UK, and I have a specialist subject doing that job, and that's really the transformation of our business here in the UK. And that's been about the last 12 months, looking at how we restructure to operate in the brave new world. So how we lean into electrification, autonomy, and mobility. So very much that's been my day job. But before that, I'm a die-hard engineer. Started back in Land Rover about 30 years ago in powertrain engineering, and then moved into BMW, worked in Germany for many years, and then over in the US for Ford before coming back here. So a research background and a product delivery background. And actually that blood still pumps deep in my veins and always will do. And so when I received the call from Dick, who's a great partner, as the auto industry is definitely generally actually at this point in time, both the auto industry and our links to aerospace and others, the community is extraordinarily strong, and we're very aligned often in our thinking. So when the Prime Minister raised the question about engagement to help this national issue, Ford was very strong in wishing to play a role and to lend our support in whatever shape that could be. And so very much the call to arms, not only from the Prime Minister, but also from Dick, helped bring us together with some fine colleagues, and very much that team set about thinking through the challenge.
So Graham, can I just follow on from that? Thank you very much for sort of telling us about that. I mean, what's the kind of the synergy between car manufacturer, I mean, and this ventilator challenge? Like, why did Dick call you, and why did you feel that you would be, and Ford would be play such an important role in this?
I think firstly, Ford is very much about the community. We operate in virtually every country around the world, and Ford being in those communities is really important. So not only providing mobility, whether that's vehicles or other solutions, it's really important that we support the community. And so this is obviously one of those massive community support requirements. And so it was an imperative really that we stood alongside our colleagues to make the biggest difference we could do. And it's not just in the UK we did that. We've done that in North America as well. But I'm really pleased at the way this project matured so rapidly. And we've been able to make our mark alongside some some world-class companies.
Thank you. And can I ask Dick then, I mean, what other companies apart from Ford are involved in the Ventilator Challenge?
Sorry. Go on.
Yeah, and how did that group coalesce? How do you get competitors who would normally be competitors, I imagine, to suddenly collaborate?
Well, there's a wide variety of companies. We've got the sort of the pace of Formula One with the support of McLaren. And I mean, to be perfectly candid, McLaren's involvement, is at a personal level. I know that McLaren had expressed an interest in doing something in this space when we knew the Ventilator Challenge was looming. And of course, the Formula One teams were grounded. So there's an enormous amount of engineering talent sitting there waiting to get its teeth into something. So that was an obvious choice to head in that direction. So I felt we needed the pace of Formula One, and it was there available, having the big company processes to get behind the challenge. So Ford, Airbus, GKN, Rolls-Royce are in there. And then once we got motoring and understanding the challenges that we were up against, it became very clear to us all that we needed the input and guidance from medical device manufacturers. So it's trying to get this whole concept. We knew we could industrialize, but can an aerospace and an automotive company make a medical device? So we started to look deep into the ISO standards around all of that, and then felt we needed to bring in some serious muscle on a medical device. So we brought in Siemens Healthineers right into the core of the activity. I think also in terms of selection of the initial companies, the initial phone calls I made, it was at a pretty visceral level. These were people who I knew would be prepared to take a corporate risk, because we didn't know whether we could deliver this stuff in the first place, for sure, and also a personal risk, because you're putting yourself into the spotlight on a national challenge. So the predominant selection criteria for those initially approached were those.
I mean, we heard this in previous COVID-19 tales of different collaborations, which is that actually what's so important about engineering is not just the ability to engineer machines, objects, cars, hospital devices, but also that relationship between people. Actually, it's a very human occupation, engineering, and that trust between people who are going to sort of say yes to something, even though they don't really know that they can yet deliver. That seems to me to be a kind of hallmark of great British engineering places like Britain. And can you tell us a little bit more about, Graham, about how you get internally that you can sort of transform saying yes to Dick into galvanizing the whole of the company?
Yeah, it's a great question, because we're a very big enterprise, about 170,000 people around the world. So trying to get the leadership team thinking in the same way, it's challenging, because this project was one where it was very ill-defined at the front end, but the mission was incredibly tangible. We all had seen the images on television. We all knew what was coming at us. And so the ability to get ourselves around the mission, around the understanding of the importance of it was there. The challenge was, would we be able to make a difference? So could we bring the right resources together around the right product? And that's where I think the partnership and the trust amongst the senior guys of Airbus and Ford and McLaren and so forth, where that trust and that belief and really looking to play to each other's strengths. And where we found we hadn't got those skills, for example, we needed a massive distribution business strapped on the side of this very quickly. We moved 11,000 parts within a month, 11 million parts, sorry, within a month. We needed someone like DHL. And so we used our networks and our relationships to bring those partners towards us. And we were managing a huge amount of money, about 120 million pounds, again, in that first month. And so ensuring that we did that wisely with partnerships like with Deloitte, we brought Deloitte on very quickly too. So I think it was the fact we were building that capability very, very quickly, that gave us confidence that we were making the right steps.
Thank you. I mean, I think later on I'm going to ask you whether you think some of those things that you learned in doing that are gonna be, you'll keep them on for future work. But I think I want to just at this point, just for our viewers out there, just to kind of go back to the basics and talk about what ventilators are and how you, in this product, having got this assembled this group of people together, Dick, and having got a set of specs from the government. How did you go what was the next steps? How did you decide on a final design? Because it's an incredibly complicated thing, and also one that none of you, I guess, mostly had ever come across before. And then how did you then gear up the manufacture?
So the rapidly manufactured ventilator specification, the RMBS, which is quite a broad specification, and it invites quite simple systems, sort of thing that you'd put somebody in just for sort of palliative support when they perhaps first come into hospital, right through to a full intensive care unit device. And of course, that specification triggered an awful lot of activity. So it wasn't just us working on the ventilators that we chose. Lots of others started with blank canvas. And I think you mentioned one of them with University College Hospital had got behind a CPAP device. As a consortium, though, having got ourselves around the table and said, what are we going to do? We decided that the quickest route to deliver something robustly was to get behind existing ventilator manufacture. So we alighted quite quickly on a Smiths Industries unit, which is a parapack device, which is used in the back of an ambulance, mostly a mechanical system. So we immediately pounced on that, had a look at the parts count, studied the component content, and started to develop a relationship with Smiths Industries. As we were working on that and beginning to form a sort of project around that, looking at how we'd do the supply chain sourcing, where we might manufacture it, the capacity at the Smiths site was quite limited, so we started to think about putting parallel factories in place at that point. And the consortium began to build a lot of industrial capability around that. We were working at risk at that point because we hadn't got any guaranteed funding from government. So again, one of the reasons why I chose companies that were prepared to put their company's resources at risk for a while. I managed to get support from the business minister, Nadeem Zahawi, to give us a letter of air cover to say, we'll support you guys, don't worry, we'll find a way of funding it. So that helped. So we started to develop a lot of industrial credibility, and towards the back end of the first week of formation, while we were studying the Smiths unit, we were asked by Cabinet Office to have a look at a second unit, which was this device from a small manufacturer in Abingdon called Penlon. And Penlon make anesthesia equipment, and Penlon had looked at the specification and had determined that by configuring some of their anesthesia equipment, so basically breaking down an anesthetic device and reassembling it into a different form, they could meet all of the specifications. So basically creating a high-end intensive care unit ventilator from anesthesia equipment. And we were introduced to Penlon by the Cabinet Office to say, you're credible as a consortium, can you get behind this device? So we sent an engineering SWAT team in on a Saturday, having phoned the managing director of Penlon the night before and said, be ready, we're about to unleash some serious industrial support on you. So we put a very sensitive small team in who spent the day looking at the device, looking at the electronics, looking at the pipework, the component count, and that team reported out to the consortium 4 o'clock that afternoon. And it was a bit like, because we did it on Zoom, it was a bit like a Capcom moment in a Saturn V launch, where we all we listened to what was being said, and we did around the table, are we ready to go? Can we make this? And it was yes, 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 yes. So at that point, we said, yeah, we didn't know all the detail, but we'd seen enough to make the decision that we'd get behind it.
So that's making the Penlon device, or
Correct.
did you make? Are you making both devices at this point?
Yeah, well, we are currently making both devices. So there's two wings to the consortium. One's looking after the Smiths unit, and the other is looking after the Penlon unit. And it's Graham that heads up basically the sub project, if you like, of the Penlon unit.
Great. So can I hand over to Graham and ask you about that Penlon moment then? So you've been basically given this task by the government to go into Penlon and see if you can basically, as I understand it, work out how to make their machine in a simpler form, but with that fits the spec, but in a very short time frame, and presumably 10,000 units or so. Is that right?
That's right. Absolutely. So that first meeting was very interesting. So we were looking at the anesthesia unit, which is a significantly larger, more complex piece of equipment. But the idea was to take some of these sub-modules and reconfigure them into a much more compact solution that's about half the price. So significantly more affordable, significantly easier to manufacture too. And the current production rate was between 6 and 10 units per week. We needed to get to something closer to 3,000 units per week. So a massive scale was required. And so we all had together a Henry Ford moment, where it wasn't about a single machine being manufactured by one individual over maybe 20 hours during a week. We had to break it down into about 250 different activities along what became one of the UK's most interesting production lines. And that production line effectively spans now from Broughton in North Wales, where the Airbus facility is, down to Dagenham, where the ventilator system is built on Ford's facility, and then out to Hook in Hampshire, where these components come back together, finally, and then into Penlon, where the final test is extremely critical to certify the machine, where that all comes together. And that process scaled from that relatively small team, about 40 people, to about 2,200 people now involved in making these machines.
What you're doing is, you're taking advantage of a massive infrastructure of engineering in the UK, and you're putting it all together and rapidly turning it around. What problems did you hit then? I mean, it sounds you're saying, the way you describe it, it sounds as complete, unambiguously success story. What problems did you have to overcome in order to kind of get that distributed system to work?
I think I'd say there were three main challenges. The first one is the part supply. There's about 700 parts in one of these machines, so they're remarkably complicated for a relatively small bit of kit. 700 parts, about 370 individual part numbers, but they come from all over the world, those parts. And so one of the biggest issues was the securing supply of some of those strategic components. And the ventilator's got a lot of modern content in it, but it's also got a lot of fairly mature technology. So quite old processes from the early 2000s, which had gone out of production. So very much the low volumes that were being built today were just using the old stuff that was available. We ended up having to reinstate production lines in Israel in order to produce those printed circuit boards and controllers. So it was, the part side of the activity was phenomenally complicated. And often we knew before we got halfway through, we would run out of parts. So we had to engineer a second solution because we knew the parts would run out on us. And we spent a lot of time, and I take my hat off to my colleagues at McLaren for their intensive activity in managing the supply chain. They managed it as you would hope a Formula One team would manage their supply chain, very, very timely, very precisely, but obviously a very complex network. And that's one example of where the government became a great ally in this project. There were often situations where countries were vulnerable, either because of coronavirus themselves or because they weren't accessible. And often the Cabinet Office would be our port of call. If we needed to get a flight into China to get some parts out quickly, we would be able to access that facility. And that was invaluable to make sure we could keep the production lines flowing.
Thank you. Dick, can I ask you something? I've got a question here from Valdemar Romero, who is in Peru, and they're in a situation where they're trying to do what Britain is doing. They're trying to rapidly manufacture some breathing apparatus fast, but without this as much of an engineering infrastructure as we've got in the UK. And the question really is, what advice do you have to do what you've done, but perhaps at a kind of, without as much infrastructure? How would you go about it?
Well, the way I'd go about it is, I mean, we chose to get behind existing supply because we knew we had the industrial muscle to do that. However, the ventilator challenge itself did give rise to a number of very credible devices which met the rapidly manufactured ventilator spec, which in my view, having seen some of them and been in discussion with some of the teams, and in fact, we had one within our own consortium, which was developed by Meggitt, the aerospace company. So there is on the shelf a design for a high specification, not exactly the full intensive care unit, but a high specification ventilator, which can be sourced from relatively conventional parts and be made by smaller industries. So such specifications exist, and I'd be delighted to put whoever it is in touch with that process. We're getting quite a few demands from other nations to say, can you help us with this specification? I think the government having created a thoughtful specification with input from clinicians and the regulator, there's been a lot of engineering effort put in behind that and some very credible devices. So I think that would be the quickest route.
And on that note, so for these designs, and presumably this also counts for some of the work you'll be doing, how did you get a regulatory approval? Because as I understand it, because you're making devices that already existed, reverse engineering, you still probably had to get regulatory approval for their use. Is that right?
Correct, yes. So because it didn't exist as an approved device, we had to go through the regulator. I think it did help with the fact that Penlon, of course, are used to dealing with the regulator. But with our support and their fantastic quality team, they got together with the regulator. The regulator knew that we were all under time pressure. It wasn't that they gave us an easy ride, because it's a very definitive process to follow. The regulator, with goodwill behind, we achieved regulatory approval in 21 days. It normally takes about 6 to 8 months. There's a lot of dead time with bits of paper, but being very focused, getting everything ready, all the information that's required, and working closely with the regulator, 21 days.
Yeah, that's incredible, isn't it?
Remarkable, yeah.
Yeah, that's really amazing. Graham, I mean, having had this experience, and now I imagine trying to gear your company up at the same time in parallel, right, to getting back into let's say normal production is probably not the right word. How has this left your company? Do you feel strong? Does Ford feel stronger because of having taken part in this partnership and still taking part in it?
I think very much that's what we're learning. We've all personally learned a huge amount, but our companies have too. To have seen the velocity of the way this team has worked, often creating processes at the same time as creating product. Data has been extremely rich through the process. There were no systems here. There was no problem-solving process. There was no anything. Even the CAD data was in multiple sources. So very much we had to grab what we had, and we created cloud-based systems, crowd-based problem-solving systems, crowd-based accounting systems. So all of that is now mineable and harvestable. And just to give you some statistics, we were solving problems, critical problems, in 22 hours on a 24/7 basis. At any one point, we had 140 problems that we were managing. And those problems were hitting us about every 14 minutes at the front of the program. So very, very fast. But the team was so focused. So we'll take a lot of that learning away. The ability for teams, when they have a strong mission, to self-organize as well and find the right combination of skills to bring to a problem. And one of the best examples of that I saw was with the Siemens team, where they involved their apprentices, ironically, in a challenge. One of the biggest challenges in the Airbus process was a needle adjustment. It was very complex to do. Over a 4-day period, the apprentices came in. They created a digital twin of the manufacturing facility, of the parts, solved the problem in the digital world, 3D printed the solution, tested it in production, and then found a way of automating it as well. And so that speed of execution we will take back into Ford, as my partners will. But I think the biggest thing is the ability to bring a diverse team together, even though many of us hadn't met personally, and to be able to rapidly trust. So choose the right people. Really important that we get the right people in the team. But then miracles are possible.
And Dick, I've got a question here from Ahmad Beltagui, who is asking a very similar thing, actually. But I mean, from the rapid manufacturing point of view, what do you take from this when we go back to whatever new normal will be?
Well, I think our ability to rise to a challenge. There's no doubt that it being a national emergency does focus the mind, and the gravity of the responsibility did bear heavy on our shoulders, but it created an incredible team spirit. And I think the key learning point for me is, because we had to empower people to get on with the job, we made rapid decisions and didn't second guess people. We had no space for any bureaucracy at all. So everything was leaned out to minimize the amount of noise. Huge degree of trust between us. And driving people and allowing them to do the right thing. And it has dawned on all of us who've been in the core of this that, why shouldn't we work like this all the time, actually? And what is it that we do within our corporations and businesses? We put good governance structures in place for good reasons. We put authority levels in place for good reasons. But a lot of these things actually end up preventing people from doing the right thing. So I think it's left us with this huge challenge about the processes that we all have evolved to run companies efficiently. That we've seen, actually, by empowering people to do the right thing, you can do things remarkably quickly. And so I think it's left us with all that enigma to solve, that how can we continue to have responsible governance of our companies, but at the same time release the talent within.
And can I just give you another question, then I'll also ask the same one to Graham, because I think both of you have different things to say. Helen, you'll ask that corporate risk was mentioned early on, and how did you manage that risk? And having managed it, will it? I mean, you sort of you alluded to it just then. How would you manage risk in the future? Dick, do you have anything to say on that, or do you want? Sorry, is
Graham frozen up? Was he?
No.
Sorry,
I thought it was directed at Graham. Sorry.
Sorry. Well, either of you, but yeah.
Maybe first. So I think firstly we like to make sure that when we've done something, we've done it properly, and the outcome is robust. But in this circumstance, we've learned that actually, if you move very, very fast and you fail very quickly, you don't actually set yourself back. You index forward, learning, and then you create the right path. So very much this ability just to execute and learn and course correct very, very quickly has been a remarkable experience. And I think if we could harness that, we will make much greater progress going forward. That doesn't mean that we put aside the analysis and the engineering, the discipline, everything else, but it does mean that we can take greater risks, I think, at the front end in putting that data in place and then making decisions on it quickly.
Yeah, I mean, this whole thing's been forged off the back of good program management discipline. I mean, that really is, I think, one of the keys to success is that all of us in the core are engineers, and we're all used to managing complicated programs. And they've got a track record in that. Graham and I go back in the car industry. We've got Siemens who make complicated medical devices. We've got Airbus that make aircraft wings, Rolls-Royce that make aero engines. So we're all used to the whole new product introduction process. The acronyms, the 3-letter acronyms, were all slightly different, but the fundamental processes are the same. And that's why you had this seamless working between these various companies, just because we all understand that process so well. It's almost intuitive. So that's why it was actually very easy to pull a program management structure together, follow the disciplines, and know where we could squeeze that process.
And Helen Ramsey asked, I mean, this is the other side of the coin, is there anything that you would have done differently knowing what you know now? I mean, there's always something, I guess.
I think both Graham and I and the others in the court would describe the whole experience as life-changing, actually. And I don't think we do that differently at all. No, I don't think we would, actually.
No, I'm completely with you, Dick. I mean, it wasn't a perfect process, and we did make mistakes along the way, but we were able to correct them quickly. And frankly, every time that happened, we learned more about what we needed to do. So I think it was the most exhilarating project I've experienced in my life. And I've built some friends. Some of them were already friends, but I built a strong trust in the people I work with, a stronger trust than I ever thought I would mature.
I've got questions here about building this trust. I mean, it seems to me that you had that to start with because you had a long working relationship between you and many of the other partners. But there must have been new people that came in. And how did you get, I mean, how did you do anything to get that trust going, or was it somehow just the fact that everyone felt that this was a national emergency and that engendered trust?
We often talked about after the event. I mean, we're still in the event, but normally what we would do is we'd bring people together. We'd maybe have an icebreaker and learn a lot about each other's past. But actually, there wasn't time to do that. So very much, people went straight into the frying pan, and we saw the best of people. We saw their strengths immediately shine through, and then learned how we were going to leverage each other. So for me, it was very much learning by doing and building relationships by doing, and it was remarkable. I think there were relationships that built in hours rather than days, weeks, and months, because we could see the strength of the new team members that were joining us.
Yes, and did you want to say anything on that, or?
No, I think just working with really top quality professionals on a single mission's just, it's a fantastic thing to do. And I think the relationships kind of automatically formed off the back of that. And this whole concept of playing to each other's strengths, but also, not everybody has strengths in all directions, so we covered for each other. And that was a very natural thing for us all to do. And when the going did get really tough, this has been and still is a roller coaster ride. I mean, there's been great highs and there's been some real, seemingly intractable problems which we've had to knuckle down and solve. And so it has got tough. But the interesting thing is we have been there for each other. Even like I said, very senior people here have been looking out for each other in this process, which has been engendered this fantastic spirit of support.
I've got a few questions here about working with the government, which presumably is something you've done before. I mean, Dick, but this is a very particular relationship, isn't it? And also the media and how coming under, being such a pivotal, being in the spotlight. This is such an incredibly important project. Can you say anything about those pressures and how you dealt with them?
Right.
And
Okay, well, take the media one first. We made a conscious decision as a team to have almost radio silence to start with. We were so busy getting on with the job. We set up a communications team, basically comprising of the communications leads of the major companies we're involved in. So they self-organized like the rest of the teams we set up, which is great. And we asked them to give us air cover. So, Consortium won't talk to anybody now. They're too busy getting on with the job, which is fair enough. So, but as we started to get on top of the game, and we knew what we were about, and we felt the need that we should start communicating, then we put a comms plan in place. And I think it's something that's been handled extremely well, just like an engineering project, consistent messaging, timely arrival of briefings and that sort of thing, and working very closely with government. Because, this has been a very hot topic, as you might appreciate. And of course now it's a great story, and we're determined on behalf of the engineering profession to make it something that we should tell. It's been a fantastic thing for industry to step up, a celebration for engineering and engineers. So we've got a real determination to play that story out fully. As far as the government relationships are concerned, we knew from the outset, because government's paying for this, then it was very important to establish a good relationship. So we've been very, very fluent in that process, daily contact, being very clear about what we're doing, setting expectations. And we have treated it like a normal professional commercial contract, even though it was forged in an emergency. It is on, professional contractual terms. And, I think it's fair to say that both government and the consortium have held each other's contractual feet to the fire through that process. Yep. But it's been entirely like a normal contract. And I would say, sorry, Graham?
I was just going to say, Dick, I would say that maybe the difference is that often there was a phone call at 8:30 or 10:30 or midnight between the consortium and government, and those individuals, those teams were working absolutely every minute as hard as we were to make sure the best solutions were available for the country. So I give them a great deal of credit in a very difficult time as well. And they were an interesting partner. They were managing some very complex things, but they were a very committed partner to us, and they really helped.
Thank you. And actually, Graham, can I just ask you a question? Signed Owen is asking, it's a slightly different question, which is about the working styles and about how this sounds a bit more like a startup business type of style. And I guess it was a sort of startup. And would you think about, now having experienced it, I mean, I'm sure you've experienced it before, but applying some of it to your everyday business?
It's funny, it's part of my day job. I was looking at agile processes that I'd like to introduce into Ford. Some of which we've already done on some of our projects. But I was struggling to work out how we could do that with some of these quite complicated and large-scale processes like our global product development system. But actually what this has taught me is that there are places, particularly when the mission is really clear, and you can bring the right team together, there are places where you can use agile process very, very effectively. So very much I'm looking now, with the limited time that any of the team have off to think about these things, I'm looking now at how I can turn that knowledge. And I have strong aspirations that not only can we use these processes in companies like Ford, but the manufacturing business can be different in a company like Ford too.
And this is, I think we're going to have to sort of stop in a minute. So I just want to give you an opportunity, and then Dick an opportunity to say anything else that you haven't said about this that we haven't kind of got to, but you feel is really important to say. Is there anything else? I mean, apart from what we've already covered, that we haven't.
Well, go on. You go first, Graham.
I was just going to say, I think it's really interesting that to have confidence to do something like this is because we have confidence in the UK's capability to do things like this. If we hadn't have had that confidence, this wouldn't have been an assignment that could have been taken. So the ability for us to reach out to partners, whether it's a tiny company in Kent that's manufacturing these flow tubes for us that we needed to supersize, or whether it's a massive enterprise like Rolls-Royce, the ability for us to reach across the whole spectrum of the UK as if they were friends, and many of them obviously are friends of the engineering industry, then that was just so inspiring. It made sure that we were confident to deliver. So Dick, over to you.
Yeah, I just actually wanted to finish on a bit of another engineering point, actually, because I think we've painted this fantastic picture about the spirit of teamwork. Another critical success factor, which I think is worthy of note, is the fact that we had like 3,000 people to train in these parallel factories. And this was a big challenge for us, because not only to train people in a very short space of time, but of course we had a COVID crisis. So the normal process would be get people in a classroom, talk them through the process, get them line side to see how it's done, with the process sheets, and work through it all. But we couldn't do that. So we had to develop an entire remote training strategy. and we deployed some really smart technology to do that. We'd started to work on, probably been working on for 18 to 24 months within the high value manufacturing Catapult, is the use of VR and AR in the workplace. So with the use of Microsoft HoloLens, of actually training people and having them in the production facility whilst in a completely remote location. And I think we had well over 100 HoloLenses in use. And yeah, we've trained 3,000 plus people through that process. It's been a remarkable deployment of some new technology, simply because the only way we could do it was to deploy new technology. So, you know, we have taken some kind of technological risks in it because we had to, but it's been quite remarkable, again, how people have responded to that, made the tools work. And we've had incredible support from businesses like Microsoft who've seen this and go, wow, you know, we want to be in. So, you know, we've been, you know, awash with HoloLens kit, and we've had Microsoft staff making personal deliveries, and it's just been incredible.
Well, thank you. That's a great on a great note to end, about the collaborative enterprise that is engineering, and how much we can all help each other. And we will need to continue to help each other, not just in terms of the pandemic and getting out of this. And of course, the ventilator challenge is still ongoing and you're still manufacturing, but also because, you know, the economy will need rebuilding. And so again, that's, engineers are at the core of that. So I'd just like to thank you both, you know, for that incredible insight. Dick and Graham, it's been an honor and a pleasure talking to you, and very, you know, we're all just incredibly, you know, pleased and amazed and proud to be you know, part of the same community as you, and wish you well, and hope and continued success. I'd just like to say to the audience, just very briefly, that the next session for this series of webinars is on next Wednesday. Wednesday the 10th of June, in fact, so a week on Wednesday, at 3:15 p.m. And it's on the delivery of the Nightingale hospitals, and it will be chaired by Elspeth Finch. You know, these hospitals have been, you know, installed in sports stadiums and conference centres, and the question being asked is, how do the Nightingale hospitals in each city differ? What unique engineering challenges did each venue pose, and what lessons can be learned for the future? And the panelists are from Mott MacDonald and BDP Engineering, and so, you know, you'll get an inside view of the project managers and the architects who delivered those hospitals in record time. And so finally, I'd like to say, you know, thank you to everyone who's been listening and sending in their questions. Sorry that we couldn't get to them all for you. I'm sorry about that. There were just so many coming in and so many interesting things being said. But I hope you felt that we really did the topic justice and the team justice. And keep tuned to the Ventilator Challenge team as they continue to deliver. I'd like to thank the Royal Academy of Engineering staff who've done a brilliant job putting this whole thing together, and you all for listening, and everyone in the Ventilator Challenge Consortium. So see you on the 10th of June, hopefully. Goodbye.